Let's review. Wow.
You said, wow.
Yeah. And then there was another one I had issues with. I think it was the quiz. Was it the quiz? Yeah. C1 and C2. But I think it's because I needed paper. Uh, all right. Oh.
All right, good morning, everyone. Good morning. Hope everybody's doing great. Everybody is all right. So, hope everybody had a great weekend. Today we're looking at 3.4. I know they're jumping all over the place with the sections, but this is where we at, 3.4 today. The last class, what was 5.1, 2, and 3. So now we have 3.4. But we're looking at percents. We talked a little bit about percents in one of our previous sections. But this one right here just goes all the way into details. That's converting between decimals to fractions to percents and so on. So I want to make sure we're okay with our conversions. And then a couple words at the end as well. As a matter of fact, when we did the percent problem before we translated to the equation, remember, what percent is, when we use the is and the of and the equals and all that stuff like that. So we're going to show you a different way of solving those same type of problems and word problems as well. So this time we'll look at using proportions, but you'll see in a second. So the word percent can be broken up into two words, per and cent. Per hundred, cent is the prefix for hundred. Remember we talked about before how per represents division. I believe it was this class when I said miles per hour, miles divided by hour. So the percent sign is the same thing as 1/100 as a fraction or as a decimal 0.01. So the first conversion practice or the first conversion type that we're going to do is decimal to percent. So it's no real calculation, just process. So locate the decimal, then you're gonna move the decimal 2 places to the right and then place your percent sign. All right, so here we have a couple examples of how to do that. If we have 0.25, we want to convert it to a percentage. Take the decimal, move it 2 places to the right, and that will be 25%. If I have 1.8, once again, take the decimal, move it 2 places to the right. Notice there was only one data value or one number to the right of that decimal, so we use a 0 as a placeholder, and that would be 180%. Got a question?
I don't know. I get it. Yeah.
All right. And then for the number 7, whenever you have a number, and it has no decimal involved, they assume you know that the decimal is to the right of the rightmost digit. So you take that value or that decimal, move it two places to the right. This time we're gonna use two zeros as placeholders. So 7 would actually convert to 700%. Mhm. All right, so here we're looking at going the other way. Hmm? Oh, no, I was talking to the class. You good. So we went to decimals to percents. Now we're going percent to decimal. So we located the decimal, then we move the decimal two places to the left this time, and we remove our percent sign. So about 37%, move the decimal two places to the left. That would be 0.37. And right here, all I was saying is that 0.37 and 0.37 are the same thing. So just remind you that it's 0 to the left of your decimal. It's fine whether you have it or not. Then 2.9%, move your decimal two places to the left. That'll be 0.029. Using 0 as a placeholder. And then 0.6%. Once again, move your decimal two places to the left. It's 0.006. That's the decimal. Mm-hmm.
On the 2.9,
Mhm.
why is it that we use the extra zero before the decimal?
Because it's always
Two places.
two places. No matter what's going on, it's always two places.
Gotcha.
Yeah. Mm-hmm. After class. Yeah, so I don't want to mess up the lecture and everything. So I'll get you after class for sure. Just don't let me forget. Mhm. Have you didn't email me about it? Any questions about this one before we scroll up to the next one? That should be good. So once again, those first two processes, the decimal to the right and left accordingly. Going from decimal to percent, I always think about moving the two places to the right and place my percent sign. And then the other one, moving two places to the right, to the left. So just think about different ways of remembering it. Okay. Next one, percents to fractions. So we want to replace the percent sign with 1/100. Remember, we talked about that in the initial introduction of this discussion. That percent sign is equal to 1/100. So we're going to replace the percent sign with 1/100, and then we're going to multiply and simplify if possible. I don't know, to the green up top. All right, so looking at 56%, once again, you're gonna start by taking the percent sign and replacing it with 1/100. From there, just multiply across. Notice I rewrote 56 as 56/1. If you want to write it as a fraction, it's the same thing as 56/1. Multiply across, 56 times 1 is 56. 1 times 100 is 100. So we have 56/100 as a fraction now. So everybody okay, going up to this point. So now from there, you have to put your skills to use as far as reducing fractions. Notice that 56 is 4 times 14. 100 is 4 times 25. Cancel out the 4s, and you're left with 14 over 25. Now, you don't always have to find the largest number. What you can do is find the number that you know, and then just keep reducing down. You know both of them are even, so nothing else. 2 can divide into both numbers. So you can start there with 2, divide both of them by 2. Still should have been even. You can divide both by 2 again, and ultimately you'll get down to 14 over 25. So if you didn't see that 4, that's in common with both top and bottom. Use what you do see, and then continue to reduce down until you get to smaller numbers, to the smallest numbers possible. But you are expected to reduce if possible.
Well, before the common.
Factor.
Yeah.
Yep, greatest common factor. Well, when you look at breaking down 14 to 25, 14 is 2 times 7. Can't break it down any further. 25 is 5 times 5. They can't break down any further. So they don't have nothing in common with top and bottom that can reduce down. So that's where you stop. So we look at, like I said, 14 is 2 times 7. 25 is 5 times 5. So nothing else can cancel. Remember, the 4 could cancel because they were in common with top and bottom. But nothing else can happen with the 14 and 25. So you just leave it like that. Mm-hmm. 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 Yeah. Same thing as if I had 10 over, let's say 6. That's 2 times 5. This is 2 times 3. The 2's cancel, and you just left with 5 over 3. If I can write it. And so that's all you have left. No, I was just telling you why we couldn't go any further with the 14 and the 25, because nothing else happens. You know, they don't have nothing else in common. So you just left with the 14 and the 25. Yeah. Scroll up, do another one. Next one, 125, 125%. That's 125 over 1 times 1 over 100. Same process. Just rewrite the 125 over 1 as a fraction, so we see a clean multiplication. You don't need it if you understand the process. I'm just doing it for board purposes, but we do need to replace that percentage with 1 over 100. So we can do our calculation. That'll give us 125 over 100. And then the same thought process. What do these two numbers have in common, if anything? What do they have in common? So we see that they have 25 in common. And 125 is 25 times 5. 100 is 25 times 4. 25 is canceled, leaving with 5 over 4.
So we didn't, like, say that, like, I think we would do like a mixed fraction or something like that. It would just be
You just leave it like that. Yeah. Question? All right, last one, and you may not even see one like this, but we're talking about one with a decimal, 0.4%. So that will once again follow the same process. You replace the percent with 1 over 100. Multiply across, that's 0.4 over 100. Now, a fraction is not truly a fraction form or not truly a fraction if it has a decimal involved. So we do need to get rid of that 0.4 in the numerator. And the way we can do that is by multiplying it by 10. 0.4 times 10 is just 4. But when it comes to fractions, whatever you do to the top, you have to do to the bottom in order to keep your equivalency. So that's why I multiply both top and bottom by 10. So I can get rid of the decimal in that numerator, and that gives me 4 over 1,000. And then from there, we can reduce both top and bottom by 4, leaving me with 1 over 250. Yes, in order to get rid of the decimal. Yep. Next conversion, fraction 2%. So we can convert the fraction to a decimal by division, and then convert decimal to percent, like we talked about earlier. Because once you cancel out that 4 completely, then that's all you left with is 1. So in other words, if you divide 4 by 4, you left with 1. If you divide 1,000 by 4, you left with 250. Well, then what are you canceling out in that 1,000 though? Are you canceling out 2 or 4? Right. Yeah.
You still have to go with this,
You have to reduce it again. And ultimately, if you reduce it all the way down, you still gonna have 1 over 250. So if you do it by 2s, or if you do it all at once by that 4, ultimately you still gonna have that 1 over 250. Hmm. All right, so 3 over 5. 3 over 5 as a fraction, the same thing as 3 divided by 5. And you throw it in the calculator, nobody's checking your long division skills. So you can just do 3 divided by 5 and calculate as 0.6. And if you move your decimal 2 places to the right, that'll be 60%. One more like this. So if I have 2 and 1/4, that 2 is your whole number, so it'll be to the left of your decimal. That 1/4, if you it will be to the right of your decimal, actually be the decimal part. So 1 divided by 4 is 0.25. And so that's 2.25. Move your decimal 2 places to the right, that'll be 225%.
So really, maybe more for yours, the fact of, doing, good old, the payment there, for the size of the debt.
Mhm. Well, these are two different examples. That's what you're saying? Mhm. So divided by four, you put that, you can just put that in the calculator, you get 0.25. Nah, nope, you going too deep. So the two is your whole number. That's just on the left of your decimal, right here. Talking about that two? The 1.4 is decimal to, the numbers to the right of your decimal. Mhm. And that's all it is. So you know, no other calculation. After you do 1 divided by 4 to get to 0.25, there's no other calculation. It's just that the two, the whole numbers to the left of your decimal, that 2.5 is to the right of your decimal. Right here? But that's the 1 divided by 4, the 1/4. Remember I was saying right here, fraction, 3/5 is the same thing as 3 divided by 5. So 1/4 is the same thing as 1 divided by 4. All right, so we're gonna take those same type of problems that we did before, like let's see, like what is 30% of 180? And we're gonna show you a different way of doing it using proportions. Remember before what we did was what was our variable is equal sign, 30% would be 0.3, of is the multiplication in 180. So I want to show you a different ways. Everybody doing that dark blue? I want to still look. Yeah. So we're gonna solve those same ones using proportions, but it's up to you how you want to solve. You can use the other what method and use this one. I just want to give you more than one way because when you look at the word problems that's right under this, proportions might be easier for you to see. Maybe not. We'll see. So we have percent, whatever your percent number, you can just place that over 100. And remember we had is and of, those numbers that we're dealing with. You can just do is over of. And when we get to the word problems, that top number is going to be your part or the partial part of it. And your base, the bottom number will be your whole, your base, the of. There's just different ways of looking at that top versus the bottom is over of. Right? So what is 30% of 180? So like I said, the easiest part is the percentage. You just place that over 100. That's 30 over 100. What is attached to the is? Of is attached to the 180. So it's just is over of. So that'll be x over 180. Mhm. So now when you have your proportion, what you can do is what we call cross multiply. take your denominators up to the opposite numerator, so that 180 up to the 30, the 100 up to the x. Because if it's a true proportion, it's supposed to be equal that way. Thirty times 180 is 5,400. Then of course on the right side, we have 100x. Divide both sides by 100, x is equal to 54. All right, try it again. That was just me rewriting it, but it's the same process. 40% of what number is 25? So 40%, 40 goes over 100. Is our what? So that goes on bottom. 25 is attached to is, so that goes on top. Cross multiply. 40 times x, 100 times 25. 40x is equal to 2,500 divided by 40, 62.5. All right. We got one more like that before we go to the word problems. We got it good. 12.4 miles is what number or what percent of 80 miles? So our percent this time is the unknown. So you place the x over 100. 12.4 is connected to is. 80 is connected to the of. So once again, it's is over of. That's 12.4 over 80. The cross multiplication. 80x, 100 times 12.4. 80x is equal to 1240 divided by 80, and that'd be 15.5. Alright. Let's go look. Maybe I couldn't wait to get to this word problem. Good. Alright, so in a recent year, the freshman class of a university had 18% Asian American students. If this represented 380 students, how many students were admitted to the freshman class? Round to the nearest students. Give somebody a chance to write it, and that's what they're trying to do. Choked you up, huh? My bad. My bad.
One of these, a couple of these.
Hmm?
We did some of these. Things that that's that.
Hmm. Mm-hmm. All right, let's try it out. So once again, we're trying this proportional setup. So 18% is just 18 over 100. Now, this one, the is and the of may not be as evident, but what we recognize is that we had a whole student body, and that's what we want to know. A whole student body, well, freshman class, a whole freshman class. And we know that 380 was a part of the whole freshman class. So that means when we look at part versus whole, the 380 is the part of the freshman class, and the whole amount of freshman students that were admitted is what we're trying to figure out, or the total amount of freshmen that were admitted. So that's going to be your bottom number. And so that's how we set it up. 18 over 100 is equal to 380 over X. So once you have it set up, then it's just the same process that you've done in the previous examples. X to the 18, 18x, and then 100 times 380, 38,000 divided by 18. That would be 2,111. And then tells round to the nearest student. So, you know, that's 2,111. Mm-hmm. Hmm. All right. Again, we'll look at another one. We got two more, this one and one more, and then that'll be it. So a real estate broker receives a commission of 3% of the selling price of a house. If the broker receives a commission of $14,370 on a sale of the home, what was the selling price of the home? Anybody holding on to the red up top? Hmm. Hmm. All right, so 3% is 3/100. And you're going to receive a 3% commission, which is a part of the actual, you know, selling price. So that's it's like a percentage of the actual selling price. And so the commission that the broker receives is 14,370. So it means the whole price of the selling of the home is what we're trying to figure out. And so that's going to be the bottom number for us, the unknown. And that part is the 14,370. Same process, you cross multiplication, take your X up to the 3, take the 100 up to the 14,370. That will give you 3X equal to, let's see, 1,433. Let me get it right. 1,437,000. And then divide by 3. 479,000.
So, no decimals are commas in
We put a comma. So, you want to.
it. I'm just trying to think about what website is that.
Comma shouldn't be necessary. You should be able to put it in just like that. Now, if a decimal was needed, then yeah, you would need a decimal. Commas aren't. Commas are pretty much optional. All right, questions before we look at the last one for the day? Make sure you're okay. All right. One more. So we got during strenuous exercise, an athlete may lose 2 liters of water per hour. If the athlete has 55 liters of body water, what percent decrease in water will the athlete experience in 1 hour of strenuous exercise? Mm-hmm. How you gonna place what now? Well, first of all, you need to look for, what do you consider your unknown? What are you looking for? Because that's going to be your variable. Yeah, so in this case, it says what percent. So you know that that's going to be X over 100. Your percent is always over 100. So if you go back to what we had before, there you go, 3%, 3%, you got the 3 over 100. So your percentage is always over 100. Now, that one should be the easy part of establishing, the easier part of your fraction, your proportion. Now, the other part is recognizing what is the part, what is the whole number, what is the whole number versus what is the piece of the total. So that's what this is. The part is always going to go over the whole. So we say an athlete may lose 2 liters of water, but if the athlete has 55 liters of body water, 2 of that is what you're talking about losing. So 2 is the part, the 55 is the whole. And so it's always the part over the total. Someone said something in the chat. Did you give, you want to just see 2? Don't know what you mean by that. Are you talking about the sections? And when you say give, what do you mean by give? You can type it in the chat. Anybody holding on to the black? So once you settle your proportion, then it's all about solving it the same way we done up to this point. You cross multiply 55 times x, 100 times 2. 55x equal to 200. Divide both sides by 55, that'll give you 3.636. And what percentage, to what decimal they want to round. So in this case, they said to the 10th place. I don't even know if they said it actually in the exercise, but I know I was looking at what they asked for in this problem. Ultimately, it was the 10th place, so that's why I stopped right there. Math lab said 10th decimal to the 10th place. That's the only way, the only reason. So if they say 100th place, you would be at 3.64, because you round 2 places. So it just depends on what math lab asks of you. Any other questions about anything we talked about in this lecture? Everybody good? Let's stay. So everybody good with this lecture? I'll cut off this recording. It's a decent one. I can hold this one.